In this lab, we're going to be exploring transmission lines. We're going to add a couple new components here that we haven't seen before. Let's start with some of the basics. We need a power supply ground. And out of signal voltage, we're going to use a new type of voltage signal called a bipolar. Basically, that's just a pulse generator that has two different levels. I'm going to go back to basics and grab a couple resistors. These are going to be simulating this voltage source, internal resistance. The new component we're going to be introducing is transmission line. Now, if you've ever been looking for a particular component and you can't find it, the search box might be helpful. If you select group and family all, and then you have some sort of indication, any information. We want a lossless, so I'm going to put in loss and do a search, and it gives me a lousy transmission line. We'll talk more about that later. It's a very pragmatic. We want to stick with a simple one, which is a type 1. So we're going to select that and put that in our circuit about here. And I think that's going to be it. Let's turn this guy around a little bit so it looks a little better. Alright, so now we're going to wire this. Sometimes this wiring, as I was just about to say, sometimes this wiring can be a bit of a challenge. We're going to take that load resistor and put it to the coax. Now, these numbers are node numbers. We'll use those to select voltages and other things later on. This is the shield, and we're going to tie both sides of the shield to ground. Now I could take this and try to tie it in. Now it's going to be easier if you make yourself sort of a foundation that then you can take this and tie it into. I find that a little bit easier. Coax to load a resistor we're using to simulate. I'm going to bump that up a little bit. Simulate the output resistance of the signal generator. Alright, so we got the components arranged. Now we're going to specify some values. On the load resistor, we're going to start with 50 ohms. The source of the internal resistance of the source, 50 ohms. The transmission line has a couple of parameters. First, we're going to say it's a 50 ohm source, and then we're going to have it simulate a delay. So there's our 2 nanosecond delay. Now all we have to do is set up the voltage source. We want the top of the pulse to be 10 volts, the bottom to be 0 or ground. We want the entire pulse to be about 4 nanoseconds long. So we're going to need to adjust that down to nanoseconds. We want the positive duration to be 1 nanosecond. Okay, now you'll also notice that 4 nanoseconds is equivalent to the frequency of 250 megahertz. Okay, so the only other thing we need to do is set up what we want to display. I'm in the wrong place, sorry. So we have set up the voltage source, so now it's going to give us 10 volt pulses. It's going to repeat every 4 nanoseconds, and the pulse duration is going to be 1 nanosecond. So let's first go ahead and save the circuit. Save early, save often. Just save that as line 01. Now there's my schematic capture file. So now we're going to introduce a new way of analyzing. If we were trying to simulate this with an oscilloscope, it probably wouldn't normal computers do what we wanted to. So we're going to actually simulate this a different way. We're going to use analysis, and this time we're going to do transient analysis. Our pulse is 4 nanoseconds long for E minus 9, and we want the output to be voltage on node 1 and node 3. It's already been selected, so we should be able to go ahead and simulate this now. And sure enough, we see this pulse that's coming out, and the important thing here, we got a 50% duty cycle, but that's okay. We got a pulse coming out at 10 volts, and that's what the voltage source is producing. But at the other end, the load resistor, we notice that what we get is a pulse, but it's delayed 2 nanoseconds, which is the propagation delay of the transmission line. And also, it's only half the voltage. Okay, so one of the things we want to do is go up here and actually save this. And it's already been selected as line 1, which is what the circuit that we're dealing with. So notice the extension is a bit different. We're going to save that, and yes, it is line 1. I've been doing this a few times. Okay, so we save that. So we've introduced a couple new concepts here. One is we've got a transmission line, which is a lossless transmission line to start with. We've got a balanced system, and the impedance is matched. We have a 50 ohm load resistor, we have a 50 ohm transmission line, and a 50 ohm source. So we've done our analysis, and we'll do a little bit more with other experiments in transmission lines. If you can get this up and running, this will give you some of the basics on how to use these new components and analysis. We'll see you next time.